Assalamu alaikum. Hello learners, you are welcome to my science class. Dear learners, today we will learn variation of weight in a lift and in space and weightlessness. Dear learners, when we use lift to get up and get down, we feel difference in our weight. At the time of lifting up, we feel weighter, that means a little bit of weighter than the previous weight, and when we get down using lift, the weight becomes less than the previous weight. And you know weight, the force by which earth attract an object towards its center. And when we basically feel our weight, suppose we apply mg force on the surface of the earth, same way earth apply that force as the object of mass of this person is m. He or she will apply mg force on the surface of the earth. Same way, the earth surface will apply mg force on this person, and that's why he or she feels his or her weight. Now this person is in the lift, and lift is a accelerated frame, and if it has its own acceleration, suppose its acceleration is a, and it basically at the time of lifting up, its direction will be upward, and the force applied by this person is mg on the floor of the lift. And similarly, lift will applied F force, and we know the gravity F equal mg, and here the applied force by lift is greater than mg, F equal ma for this lift, and the applied force F is greater than mg. Why F is greater than mg? If F is greater than mg, then lift will go upward. Here we can write resultant force mg equal ma. Applying this force in this formula, this is resultant force F minus mg equal ma. Now we can write ma minus mg. A minus g at the time of lifting up. Now at the time of lifting down, the acceleration acts downward, and the force applied by the person on the floor of the lift is mg, and lift will apply F force on the person, and now mg is greater than F. That's why lift goes downwards, and we know F equal ma. Now resultant force, as mg is greater than F, resultant force F equal ma. Now minus mg plus ma, F minus m, g minus a. We can write here, it's a mistake, it will be F equal m, g minus a. Look here, the apparent force will be more at the time of lifting up, and here less. When lifts go downwards, you feel less weight. When lift go upward, you feel more weight. What happens when rope of lift basically disconnected? Then at that time we can write F equal m z here. At that time, acceleration of lift equal the acceleration due to gravity. If we put g instead of a, we will get m z minus z equal 0, and it is weightlessness. Now, dear students, what is weight? The attraction force of earth towards an object is its weight. This person applied mg force on the surface of the earth. The same way the earth applied mg force towards this person. That's why we feel, or this person will feel his or her weight. At the time of lifting up, this person applied mg force on the surface of the lift. At the time of lifting up, the lift applied F force. It accelerates at a acceleration, using a acceleration. So at the formula of gravity, F equal ma or mg, we know F equal ma, and here the force applied by lift will be greater than the weight of that person. And here if we now we will get resultant force F minus mg equal ma, F equal ma as changing the side mg, and the weight will be more at the time of lifting up. Now lifting down, the time of lifting down, the acceleration a, but it acts downwards. The force applied by the person mg and lift applied F force on the person. At that time F will be smaller than mg. That's why lift basically goes downwards. Mg minus F, resultant force, applying this formula. Now the changing the side or simplify the equation, we will get F equal mg minus a. That means the apparent weight will be less than the real weight. Now when the rope of lift tears, that time the acceleration of lift will equal to the acceleration due to gravity, and if we put this value in this equation, we get F equal 0. That means force no weight. This is weightlessness. It is known as weightlessness. That's all about our today's topic. Thank you. Assalamu alaikum.